Hello and welcome back. Today we're talking about Newton's method. So what Newton's method does is it finds approximate roots for a function that it might be impossible to find the root for. So what it is we're going to take a guess. We would call that x0, x0, whatever you want to call it. And we're just going to use our function, which in this case is this. And we're going to find the prime of that function, which I've already done. And so we're just going to plug those into this formula to get a closer guess. And eventually you'll notice there's almost no difference in the guesses. So I've made this table, xn, f of xn, f prime of xn, and then xn plus 1, which is just the next row in the table. F of xn, well, let's get started. So I know I used a graphing calculator here to find that the root is just short of x equals -2. But let's find out very closely what this root is. So let's find our f of xn. F of xn is going to be -2, -8, it's -2 cubed, plus 4, plus 3, that's -1. Our f prime of xn is going to be 3 times 4 minus 2, that's 12, minus 2 is 10, so our x of n plus 1 is going to be -2 plus 1/10, so that's 2.10, I'll do 0, 0. I don't know if we'll actually get down to it, but we'll see. Or no, sorry, that's -1.900. -1.900. Forgot my negative sign. That can be horrible to do in this situation, but we got it. So we're going to plug in -1.900. Now I'm going to use my calculator here. -1.900 cubed plus 2 times 1.9 plus 3 is going to be -0.059. And then we're going to get our f prime, that's 3 times 1.9 squared minus 2 is 8.83. And so what we're going to get here is we're going to get 0.059 divided by 8.83. That's going to be what we are minusing from here, or adding, sorry, because of this negative. We're going to add that to 1.9, and we get 1.907. -1 point. Oh man, keep doing this wrong. It's not actually that. 0.059 divided by 8.83 is negative that, so plus or minus 1.9 is -1.893. So let's plug that in for x3. Wow, I'm not on my game today. -1.893. Let's do it again. So our original function of -1.893 is -1.893. We're going to cube that. Then we're going to minus 2 times -1.893. We're going to add 3 to that. It's a very, very small number. 2.53 times 10 to the -3. f prime of x to the n, or xn, sorry, is 3 times negative 1.893 squared minus 2 is 8.875, or 8.75. So 2.53 times 10 to the negative 3 equals, divided by 8.75 equals very, very small number. We're going to subtract that from negative 1.893, and we should get, yeah, very close, negative 1.893 again. So you might notice these numbers are actually the same, so we don't need another 2 rows that I gave myself there, which is, I mean, that's very good. That means we made a very good guess. Negative 2. I kind of got given it by my graphing calculator, but a lot of the times on a test or an assignment or whatever, you will be given either a graph of it or just an initial guess. So it's very simple. I mean, a lot of the times you just get a normal polynomial like that. It could be worse, but a lot of the times you'll get a really easy function. It's just a lot of number crunching, and you got to make sure to not make any mistakes. I'm really bad for that. I'm always making mistakes on this, but you can usually tell when you make a mistake. If you make, I mean, if I went from negative 1.893 to like 3, that'd be really inaccurate. Usually your steps are going to get smaller and smaller as you keep going, eventually approaching 0. And so let's just do a quick little check here. Yep. The exact root is negative 1.89329. So perfect to those decimal places. And that's what's going to happen. This is how calculators and other things like that, computers, calculate roots. It was interesting. I actually made one of these in my computer programming class. It's very fun to do. But yeah, that's Newton's method. Thanks for watching.